Okay, pre-algebra, we're starting Unit 2. Similar to Unit 1, we are doing some review in Unit 2 of some topics you should have seen. Some topics would be a little bit new, but reviewing some things about our number system. So if we look at our number system, right now in pre-algebra, we're focused on what are real numbers, okay? Later in upper school, you'll talk about things that are complex numbers, but for right now, real numbers, things that are concrete to you, like you know that we have two desks or two chairs, things you can count, or if you can't count them, like the square root of 2, okay? Numbers that are always real. So we break them up into different categories, okay? So if you look there on the left, what are called our rational numbers. So rational numbers are numbers that can be written as a fraction. So a rational number can be written as a fraction of two integers, 2/3, 4/5, 3/6, okay? I can write that. The number 5 is 5 over 1, okay? If you look at 3.4, that's 3 and 4/10. Okay, you can convert that to an improper fraction. Okay, now if I look within the rational numbers, I have different sets of numbers. So the natural numbers are sometimes called our counting numbers. And this should be easy for you to remember because if you ever start counting things, you typically start with ones. So 1, 2, 3, 4, etc. Okay. Now, I realize you could count by twos or count by threes, but if you're actually trying to enumerate things, you count by ones, okay? So when I look at those numbers, they're all positive. They start with 1, okay? How many counting numbers are there? Well, there are infinitely many, but it's a countable infinite. So for example, if you give me a natural number, I can always tell you the next one. So I could keep naming them over and over again, okay? Whole numbers are just the counting numbers, and 0. So basically it's the same list, but it just starts with 0, 1, 2, 3, and so forth, okay? So there's 0, which is neither positive or negative, and then all the counting numbers. One thing about, you think about whole numbers is like, just make a sentence. If you have a number, does it make sense to say, say 3, I ate 3 whole pieces of candy, okay? 1/2, I ate 1/2 whole piece of candy. That doesn't make sense. So whole numbers are things that are countable that are whole pieces, okay? Now the integers, if you think about it, is just, that's where we enter with positive and negative. So basically it's the natural numbers and their negatives and 0, okay? So this is, -4, -3, -2, -1, 0, 1, 2, 3, and so forth. Basically, it's the whole numbers and then all the negatives of the those positive numbers. Okay, and then if we go further up, so we've got natural numbers, whole numbers, integers, and then rational numbers are numbers that can be written a over b, where a and b are integers and b is not 0. So 2/3, 3/2, 4, because 4 can be written as 4 over 1. 0 can be written as 0 over 1. Okay, so these are your rational numbers. Any fraction that can be written as a fraction of integers. If I write 3.5, remember that's 3 and 1/2, which is 7/2. So 3.5 is a rational number. Okay, now an irrational number, okay, an irrational number is a number that is, and we don't really like definitions like this, but a number that is not rational, okay? So basically, if you look at the camps up here, rational numbers can be written as a fraction of integers. Irrational numbers cannot. Examples of irrational: pi, it's a decimal that never terminates and never repeats. The square root of 10, okay? The square root of 9 is 3. The square root of 16 is 4, okay? But the square root of 10, what number you multiply by itself to get 10, is not an integer value. Okay, so these are the irrational numbers. So examples of that, the square root of 2, pi, things like that, okay? Show the number 1.45 as a rational number. So this is 1 and 45 over 100. In this class, you should be conditioned to reduce every fraction you can. So if I look at that, I can divide 5 into that. So this is 1 and 9/20, okay? Convert it to an improper fraction. This is 29 over 20. And that is a rational number because it's written as a fraction of 2 integers. Now, as long as a decimal terminates or repeats, it can be written as a rational number, okay? Now, you may not have done this before, but how can I show you that 0.2 repeat is a rational number, okay? So here's where we have to do something a little bit algebraic, okay? So I'm gonna write x equals 0.2 repeat. That means that 2 goes on forever, okay? Another way of thinking of this, x is 0.222. That's the same thing. The 2 goes on forever, right? Now, what happens if you multiply a decimal by 10? So 10x, that's going to move the decimal one place. So 10x is going to be 2.2 repeat, okay? Okay, so all I did, when you multiply a number by 10, you make it larger and you move the decimal one place. So what I can do is now I can write that right up here. So 10x is 2.2 repeat. Now what I want to do is set up a subtraction. 10x minus x is 9x. 2.2 repeat minus 0.2 repeat is simply equal to 2. And now, if you divide both sides by 9, you get x equals 2/9. This is how you show a repeating decimal is a rational number, okay? Now, you're going to see this on a quiz or a test, and this is what I expect to see. I want to see the algebraic work that gets me the answer. Now, you may look at this and remember that 0.2 repeat is 2/9, and good for you, but I want you to show me how we prove that. Let's look at another example. X equals negative 1.3 repeat. So I'm going to do the same thing. X equals, okay, I'm going to save the negative, just leave it off the side. Let's just work with it as a positive. So 1.3 repeat, okay? If I multiply this by 10, the decimal moves one place to the right, and I get 13.3 repeat. Set up a subtraction again. So 10 minus 1 is 9x equals 13 minus 1 is 12. So x is 12/9. That's partial credit. Divide those numbers by 3 and you get 4/3. So this answer, since it's negative, is negative 4/3. Now the other way you could have done this is you could have just focused on the 0.3 repeat. So if I say 0.3 repeat, then 10x is 3.3 repeat. Set up the subtraction. 9x equals 3, x equals 3/9 or 1/3. So it tells me that this part right here is just 1/3. So that makes this number negative 1 1/3. So either one of those would have been a good, correct answer. Where it's a little bit different here is 0.12 repeat. So x equals 0.12 repeat. So here the repeat is 2 digits. I need to multiply so that I get a number that has the same repeat. So I need this decimal to move 2 places. In order to do that, I have to multiply by 100. 100x is 12.12 repeat. Set up my subtraction. 99x equals 12. So x is 12 over 99. Those numbers are divisible by 3. So 4 over 33. If you check it on your calculator, 4 divided by 33 is 0.121212. Okay. Negative 0.23 repeat. The answer is going to be negative. Let's just work on the 0.23 part. So x equals 0.23 repeat. I need the decimal to move here. So 100x equals 23.23 repeat. Set up a subtraction. 99x equals 23. So x is 23 over 99. So the final answer is negative 23 over 99. Negative 101.7 repeat. So all I really need to focus on is that 0.7. So x equals 0.7 repeat. To get the decimal here, 10x equals 7.7 repeat. So 9x equals 7, x equals 7 ninths. So this number is negative 101 and 7 ninths. If I add these numbers together, 1.2 repeat, 3.7 repeat, this is 4.9 repeat. So if x is equal to 4.9 repeat, 10x is 49.9 repeat. Set up a subtraction. 9x equals 45. So x is 45 over 9, which is 5. So that is a rational number. Okay. If I use this grid to show the value of 2 squared, okay, well, 2 squared just means 2 times 2, okay? It's repeated multiplication, okay? Multiplication is just repeated addition. So all it means is that you're adding 2 twice. So here's 2 and here's 2. So that is equal to 4. If you look at the value of 3 squared, that's 3 times 3. Okay. So what this means is you're multiplying. You're going to have 3 3's. Okay. So this is 3, 3, and 3. Okay. So this is going to be 9. So 2 squared is 4. 3 squared is 9. Okay. So this is what I get when I square things. The inverse of squaring is the square root, okay? So the square root of 9, you're looking for a number that you multiply by itself to get 9. That number is 3. The square root of 4 is 2, a number you multiply by itself to get 4. So the way we'll write this is with the square root sign, the radical, the square root of 9. What number do you multiply by itself to get 9? The number is 3, okay? 9 and 4 are called perfect squares because the number that you multiply by itself to get there is an integer, okay? Now, 2 is not a perfect square because if I try to find the square root of 2, is there a number I can multiply by itself and get 2? Well, 1 times 1 is 1, 2 times 2 is 4. I've already gotten too big. So somewhere the number has to be between 1 and 2. Okay, so this is not a rational number. The square root of 2 is not rational because I can't come up with an integer value that you multiply by itself to get 2. So if I look at numbers like 67, okay, this is a real number. Okay. Is it a counting number, a natural number? Yeah, if you count, you'll get to 67. Is it a whole number? Yeah, those are I ate 67 pieces of candy. That makes sense. That's a whole number. Is it rational? Can you write it as a fraction? Yes, okay. Is it irrational? Answer is no. Is it an integer? Yes, okay. Remember. Now if I look at negative square root of 9, square root of 9, is there a number you multiply by itself and get 9? Well, the answer is 3. This number is negative 3. Is that real? Yes. Is that a whole number? Whole numbers, 0, 1, 2, 3 is not. Is that a natural number? 1, 2, 3, 4, 5? No. Is it rational? Can I write it as a fraction? Yes. And if you look at our beginning, numbers either fall in one camp, rational or irrational. They don't fall in both of those. So once I've determined it's rational, can't be irrational. Is it an integer? Is negative 3 an integer? Yes, that is. 0. Is that a real number? Yes, that is a real number. Is it a whole number? 0, 1, 2, 3, yes. Is it a natural number? 1, 2, 3, 4, 5, no. Is it rational? Can I write 0 as a fraction? Well, yeah, 0 over 1. Irrational? No. Is it an integer? Yes. Pi over 0. In this class, anytime 0 on the bottom of a fraction, there is only one word you will ever use. This is undefined. Okay? None of those other things apply. Point 1, 2, 3, repeat. What we showed on the previous page is anytime a decimal repeats, it is rational. Okay, so I know it's rational because repeating decimals are rational. Is that real? Yes. Is that a whole number, like 0, 1, and 2? No. Is it a natural number? No. Is it an integer? No. The square root of 2. Okay, this is a real number. It's not a whole number like 0, 1, 2, 3. It's not one of my natural or counting numbers. Square root of 2 is not rational because like the square root of 4 is 2, but the square root of 2, I can't get an integer value of that. This is an irrational number, and it's not an integer value. The square root of 27. Well, the square root of 25, remember that's 5 times 5, but the square root of 27, that's not a perfect square. So this is real. It's not a whole number. It's not a natural number. It's not rational because it's not a perfect square. It's an irrational number. 8.67, that's real. It's not a whole number. It's not a natural number. It's a decimal that terminates. That makes it rational, and it's not an integer. The square root of 400. Is there a number you can multiply by itself and get 400? On your calculator, you've got a square root button. You could put in the square root of 400 and you're going to get 20 because 20 times 20 equals 400. So this number is real. It's whole. It's natural. It's rational. And it's an integer. 0 over pi. This is just 0. Okay, 0 is real. It is whole. It's not a natural number because those start with 1. Is it rational? Yes. Irrational? No. Is it an integer? Yes. Okay. So what this just shows is your thinking process of how we categorize number, being able to categorize them. How many integers are between 6 and 11? So if you had a number line here, 6, 7, 8, 9, 10, 11. Okay. So how many integers are between? So 7, 8, 9, and 10. I see 1, 2, 3. There are 4 integers between 6 and 11. How many whole numbers are between 0 and 5? So here's 0, 1, 2, 3, 4, 5. These are all whole numbers. Okay, so there are 4 whole numbers between 0 and 5. How many rational numbers are between 0 and 1? So here's 0, here's 1, Well, so 1/2 is a rational number. 3/4, 1/4. What do we think? There are infinitely many numbers in there. You know, you could do like 3/4, 4/5, 5/6, 6/7, 7/8, 8/9, 9/10. Okay, so they're infinite. So infinite number of rational numbers between 1 and 2. How many integers are larger than 100? Okay, so if I'm counting integers and I get to 100, then I go 101, 102, 103. How many of them are there that are bigger than 100? There's an infinite number of integers bigger than 100. What is a rational number between 9 and 10? So if you've got 9 and 10, well, 9.5 works, okay? That is one. It's not by any means the only number, 9.6, 9.7, 9.8, 9.9, 9.99, okay? All you have to do is just pick a number that's a terminating decimal or fraction in between there. You could just say, or you could have said, 9 and 1/2, or you could have said 19 halves, any of those. What is an irrational number between 9 and 10? Now this one's a little bit tricky, an irrational number between 9 and 10. So what you want to do here is, here's 9, here's 10. What I want to do is I want to square those numbers. Okay, so 9 squared is 81. 10 squared is 100. So what I need is, what's a number between, so those are the perfect squares, okay? What is a number between 81 and 100? Just pick a number, okay? All you have to do is pick any number between 81 and 100, like 85. So the square root of 85 is somewhere in between here, okay? And that's an irrational number. Because 85, I can't think of an integer number that you multiply by itself to get 85. So again, the trick there was when I'm looking for an irrational number between two numbers, square the numbers you have. Pick a number that's between those two, and you're just taking the square root of that. What is an irrational number between 1.5 repeat and 1.6 repeat? Okay, so if I think about it, so 0.5 repeat. So if x equals 0.5 repeat, 10x equals 5.5 repeat, do the subtraction. So 9x equals 5. So that's 5/9. So this is a number between 1 and 5/9. And then 1.6 repeat. So if x equals 0.6 repeat, 10x equals 6.6 repeat, subtract, 9x equals 6, x equals 6/9. So this number is 1 2/3. So if I look at this, this is, put it into improper fractions, a number between 14/9 and, what is this, 5/3. So I need a number that's in between there. Let's convert this to the same denominator. So a number between 14/9 and, if I multiply by 3, 15/9. So I need a number that's in between those two numbers. So you could just split the difference, okay? So you could say 14/2, so you could say 14.5 divided by 9. That is a rational number between 1.5 repeat and 1.6 repeat. What is an irrational number between 1.5 repeat and 1.6 repeat? So an irrational number. So again, the trick with the irrational numbers is to square the number you have. So remember, this was what, 14/9, and this guy was 5/3. So if I square these numbers, okay, so 14 squared, so 14 squared is what, 196. So when I square them, it's 196 over 81. Square the other one, and you get what, 25 over 9. Okay. So I just need a number that's in between these and take the square root. Okay, so 196 over 81. So 196 divided by 81, what, about 2.41? And 25 over 9, so 25 divided by 9, about 2.7, something like that. So I just need to take the square root of a number in between there, okay? So I could just say the square root of 2.6. I know that's going to be an irrational number because I know that this is a perfect square and this is a perfect square. You can take the square root of those. Okay. You are given the expressions 76 plus n and 2n plus 26. What is the smallest positive numbers for n that make the expressions rational? Okay, so the square root of 76 plus n. So what I'm looking for are what is a perfect square that's bigger than 76? That is, when you square something and you get a number bigger than 76, what is 8 times 8? 64. 9 times 9 is 81. Okay, so 81, that's the next perfect square. So if I had an 81 under there, I could take the square root, okay, and get 9. So what I need here, I need for this to be equal to 81. What do you add to 76 to get 81? N would have to be 5. Now there's another perfect square after 81 is 100. That's 10 times 10, but that would give me a bigger value. Okay. 2n plus 26. So what you want to key is on this number, 26. That's not a perfect square. 25 is a perfect square. That's 5 squared. Okay, what's the next perfect square after 5 squared is what? 6 squared. So that's going to be 36. So I need 2n plus 26 to equal 36. If you subtract the 26, 2n equals 10, so n is 5. So n is 5 is the smallest number that makes both of those guys rational. Okay, and that leads you up into homework for this section. Okay.